Dear students, in this video, I am going to discuss solutions of numerical problems appeared in the July 2015 physics question paper. Let's have a look on the very first problem. ABCD is a square of side 2 meter. Charges of 5 nanocoulomb, 10 nanocoulomb and minus 5 nanocoulomb are placed at corners A, B, C respectively. What is the work done in transferring a charge of 5 microcoulomb from D to the point of intersection of diagonals? Here we have a square ABCD. This is ABCD of side 2 meter. That is 2 meter, 2 meter. So the charges of 5 nanocoulomb, let me consider here there are 3 charges. Let me consider the Q1 equals to 5 nanocoulomb, that is 10 raised to minus 9 coulomb, and Q2 equals to plus 10 nanocoulomb, and Q3 is equals to minus 5 times 10 raised to minus 9 coulomb. So let me place here the A. At A, Q1 charge is present, at B, Q2, at C, Q3 respectively. Work done in transferring a charge of 5 micron, that is charge to be transferred. Charge to be transferred is how much? Is, let me consider this Q, it is equals to 5 microcoulomb, that is 5 times 10 raised to minus 6 coulomb. So from where to where? From D to the point of intersection diagonals. Let me draw the diagonals here. That is AC is one diagonal and DB or BD is one diagonal. This is the point of intersection of the diagonals. Now what is the work done to move the charge Q from D to O? To find out this one, we need to find out now the potential difference between these 2 points. To find out the potential difference, we must have potential. We must have the potential at D and potential at O. So therefore, first let me take potential at O. Why we are finding? Because we need to find out the work done in transferring the charge from D to O. So work done is equals to potential difference times the charge to be transferred. So that is V naught minus Vd, that is potential at O minus potential at D into charge to be transferred. So to find out VO, we need to use the superposition principle. That is VO is equals to, according to superposition principle, the resultant potential at O is equals to the algebraic sum of all the potential due to all the charges at this point, that is at O. That is Q1 by AO, the distance between O and A is AO, plus Q2 by BO plus Q3 by CO. So now we need to substitute AO, BO and CO. So let me find out AO, BO and CO. Here from the Pythagoras theorem we know that AC is equals to, or else AC square is equals to, we can have from the Pythagoras theorem AC square is equals to AD square plus DC square. This can be written as 2 square plus 2 square. This is equals to 8. That is AC square is equals to 8. So therefore AC is equals to, that is root 8. Root 8 is nothing but root 2 meter. That is AC is equals to 2 root 2 meter. But we want AO, BO and CO. So we know that AO is equals to, BO is equals to, CO is equals to DO in this square. So this is equals to half of the diagonal, that is AC, that is 2 root 2 divided by 2. This is equals to root 2 meter. Okay, so let me substitute now. V naught is equals to 1 by 4 pi epsilon naught is 9 times 10 power 9. Q1 we have here, that is 5 into 10 raised to minus 9 divided by AO equals to root 2 meter plus Q2 equals to 10 into 10 raised to minus 9 meter divided by root 2, and here Q3 equals to minus 5. So we are taking here minus 5 into 10 raised to minus 9 divided by root 2 meter. Now observe here minus 5 into 10 to the power of minus 9 divided by root 2, and here plus 5 into 10 raised to minus 5, 10 raised to minus 9 divided by root 2. So here we have plus and here we have minus, and same magnitude, so these two will get cancelled, and then we'll get only 9 into 10 raised to 9 into 10 into 10 raised to minus 9 divided by root 2. And here 10 to the power of minus 9, 10 to the power of plus 9 will get cancelled. We will get 90 divided by root 2. So 90 divided by root 2 is nothing but, that is 90 divided by 1.414, that is V naught. So therefore V naught is equals to, that is 90 divided by 1.414. This is equals to 63.64 volt. 63.64 volt. Now, in the same way, we need to find out the potential at D, that is Vd is equals to 1 by 4 pi epsilon naught, that is Q1 divided by Q1. Where is the Q1? At A. So therefore, we can take AD, that is we need at D. So therefore, from A to D, AD plus Q2, which is placed at B. So we can take BD plus Q3, which is placed at C. So therefore, we can take CD. Now substitute the values, that is Vd is equals to 1 by 4 pi epsilon naught value is 9 times 10 to the power of 9, and Q1 is equals to, we have seen that Q1 equals to 5, Q2 equals to 10, and Q3 equals to minus 5. So let me take Q1 is 5 into 10 raised to minus 9 divided by AD equals to 2 meter, plus Q2 equals to 10 into 10 to the power of minus 9, and BD equals to, so we have seen that BD is equals to, that is the length of the diagonal is equals to how much? BD equals to AC. You have seen that AC equals to BD equals to root 2 meter. So we can take now 2 root 2 minus Q3 is minus here, so we are taking minus 10 to the power of minus 9 divided by CD equals to 2. So VD equals to, now 9 into 10 raised to 9, and here 5 into 10 to the power of minus 9 divided by 2, this is plus and this is minus, so both will get cancelled, and we will have only 10 into 10 raised to minus 9 divided by 2 root 2, and 10 to the power of minus 9, 10 to the power of plus 9 will get cancelled. We will get 90 divided by 2 root 2. 90 divided by 2 root 2 is equals to, that is VD 90 divided by 2 root 2 will be equals to 31.82 volt. This is the potential at D. So we need to find out the work done in transferring the charge from D to O. So therefore, we have a formula for work done, that is work done is equals to potential difference, that is VO minus VD, potential difference into charge to be transferred. So here we have the V naught is equals to 63.64 minus VD equals to 31.82, and charge to be transferred is, so we have charge to be transferred 5 into 10 to the power of minus 6, 5 into 10 raised to minus 6. This is equals to 63.64 minus 31.82 is 31.82 times 5 into 10 raised to minus 6. This is equals to 159.1 into 10 raised to minus 6 joule. This is the work done in moving a charge from D to O, or point of induction diameter. This can be written as 1.591 into 10 raised to minus 4 joule. This is the work done in moving a charge. Okay, so let's have a look on the next question, that is, two identical cells either in series or in parallel combination gives the same current of 0.5 ampere through external resistance of 4 ohm. Find EMF and internal resistance of each cell. Here the number of cells are 2. How many number of cells we are having? 2 cells, and which are either in series or in parallel, which gives the same current, that is IS, current in series combination, and current in parallel combination is same, that is 0.5 ampere. through an external resistance, that is R equals to 4 ohm. So we need to find out EMF and internal resistance of each, that is EMF and internal resistance of each. We know that whenever the cells are connected to the external resistance, the current is given by the expression current is equals to EMF divided by R plus R. If the cells are connected in series, then it will become IS is equals to ES divided by R plus RS. So now for identical cells, cells connected in series. For identical cells connected in series, we will be having ES equals to NE and resistance, that is effective internal resistance, RN is equals to, RS is equals to NR. So therefore this equation becomes now IS equals to NE divided by R plus NR. Let me consider this is equation number 1. Now if the if the cells are connected in parallel, then the IP is equals to, we know that I is equals to E divided by R plus R. Suppose if they are connected in parallel, then we will get IP equals to EP divided by R plus R. We know that for identical cells, connected in parallel, we get EP equals to E. If the cells are connected in parallel, then effective EMF is equals to E, and the effective internal resistance, that is RP is equals to R by N. So for identicals connected in parallel, we can write EP equals to E and RP equals to R divided by N. Then this expression will become now IP is equals to EP. In place of EP, I am writing E divided by R plus, in place of RP, I could write R divided by M. So this will become now, if I take this E divided by, that is NR plus R divided by N. So this will become now NE divided by NR plus R. So therefore IP is equals to NE divided by NR plus, let me consider this equation number 2. So according to this question, this IP is equals to IS. IP is equals to IS. So therefore from equation number 1 and 2, we could write IS is equals to IP. Therefore here, according to this question, IP is equals to IS. So IP, here we got NE divided by NR plus R, NE divided by NR plus R, whereas IS is equals to NE divided by R plus NR. Now on substituting R, else NE get cancels. Now we will get NR plus R equals to R plus NR. And substituting the values, you will get N equals to 2 and external resistance equals to 4 plus internal resistance, we don't know, that has to be determined. And R, we know that 4 plus N, number of cells 2, and this R. Now on simplifying this, we will get R equals to, that is 8 plus R is equals to 4 plus 2R. So therefore we will get R is equals to 4 ohm, that is internal resistance is equals to 4 ohm. On substituting this value in any one of the equation, that is 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 equals to, let me take IS is equals to NE divided by R plus R, NR. So we know that IS. So IS we have here 0.5 ampere. So we can have here 0.5 ampere, and this is equals to N, number of cells 2, and EMF has to be determined. R is equals to 4 ohm plus N, number of cells. R and internal resistance just now we determined, that is 4. So this will become now 2E divided by 4 to the 8 plus 4, 12, that is 0.5 here. Now 2E is equals to 6. So E is equals to 3 volt. So these two cells, that is identical cells, having the EMF E, therefore EMF is equals to, EMF of those two cells is equals to 3 volt, and internal resistance R equals to 4 ohm. Okay, let's have a look on the next question. A resistor of 100 ohm, a pure inductance coil of L equals to 0.5 Henry, and a capacitor R in series in a circuit containing AC source of 200 volt 50 Hz. In the circuit, current is ahead of the voltage by 30 degree. Find the value of capacitance. So in the problem, the value of resistance is equals to 100 ohm, and inductive reactance, that is 0.5 Henry, and the voltage of the AC source, that is 200 volt, and the frequency of the AC source is 50 Hz. In the circuit, the current is ahead of the voltage, that is current leads the voltage by 30 degree, psi equals to 30 degree, that is current leads the voltage by 30 degree. So therefore we can take the capacitive reactance is greater than inductive reactance. So now we need to find out the capacitance of the capacitor. We know that an expression for the capacitance is a capacitor reactance, that is equals to 1 divided by 2 pi Fc. This is the expression for the capacitive reactance. So now we can get the capacitance of the capacitor from this expression, that is 1 divided by 2 pi F into Xc. Now to find out Xc, you can make use of the formula, that is tan psi is equals to Xc minus XL divided by R. So Xc equals to tan psi into R plus XL. Now substitute the values, that is Xc is equals to tan psi is equals to, that is tan psi equals to 30, R is equals to 100 plus XL is nothing but 2 pi FL. So now tan 30, the value of tan 30 is 1 by root 3 times this 100 plus 2 into 3.142. The frequency is 50, and L, inductive reactance, that is 0.5, inductance 0.5, this is equals to 100 divided by root 3 is 57.73 plus this is equals to 157. So this will become 214.73. This is the value of Xc, that is capacitive reactance. So after getting this one, just you substitute this Xc in this formula. So now, so therefore the capacitive reactance, the C is equals to 1 divided by, let me write C is equals to, here C equals to 1 divided by 2 pi f Xc, 2 pi value is 3.142, f is equals to 50 Hertz, and Xc just now we found 214.73, 214.73. This is equals to, that is capacitance of the capacitor is equals to 1.48. On simplifying this, we will get 1.482 into 10 to the power of minus 5 farad. Okay. So this is the capacitance of the capacitor. Okay, let me go for the next question. That is, a beam of light consisting of two wavelengths 4200 angstrom and 5600 angstrom is used to obtain interference fringes in Young's double slit experiment. The distance between the slits is 0.3 millimeter and the distance between the slits and the screen is 1.5 meter. Compute the least distance of the point from the central maximum where the bright fringes due to both the wavelengths coincide. Here we have two wavelengths, that is 4200 angstrom and 5600 angstrom. Let me take 4200 angstrom as lambda 1, that is 4200, and 5600 angstrom as lambda 2. And distance between the slits is, that is small d equals to 0.3 millimeter, and distance between the slits and the screen, that is capital D equals to 1.5 meter. The least distance of the point from the central maximum where the bright fringes due to both the wavelengths coincide. So bright fringes, we know that the distance of the nth bright fringe, the distance of the nth bright fringe, nth bright fringe from the central fringe, from the central fringe is given by, that is xn equals to n lambda d divided by d. This is the expression for distance of the nth bright fringe from the central bright fringe. Now, so distance of the bright fringe which is from the lambda 1 is equals to xn1 equals to n1 lambda 1 d divided by d, and distance of the bright fringe which is obtained by the second wavelength, that is xn2 equals to n2 lambda 2 d divided by d. So in the question they are saying that the bright fringes due to both the wavelengths coincide. That means the distance of the bright fringe obtained by the lambda 1 is exactly equals to distance of the bright fringe obtained by the lambda 2. So therefore xn1 equals to xn2 according to this question, that is xn1 is equals to xn2. This is a given data. Okay, in the question they are saying that the bright fringes will coincide. If they are coinciding, the distance of the bright fringe formed by the lambda 1 is exactly equals to the distance of the bright fringe formed by the lambda 2 will be equal. So we can write like this. So now this is equals to, that is xn1 is equals to n1 lambda 1 d divided by d, and xn2 equals to n2 lambda 2 d divided by d. So therefore we will get n1 by n2 is equals to d get cancels, capital D small D small d will get cancelled. We will get n1 by n2 is equals to lambda 2 by lambda 1. This is equals to, here lambda 2 is 5600 angstrom and lambda 1 is 4200 angstrom. So here 56 divided by 42, this is equals to 56 divided by 42, that is n1 by n2 is equals to 4 divided by 3. So therefore n1 equals to 4 and n2 equals to 3. So if you substitute n1 equals to 4 in the equation, this expression, we will get the distance of the bright fringe where both are coincident. That is, we know that xn1 is equals to, that is xn1 is equals to n1 lambda 1 d divided by d. Just now we got xn1 is equals to 4 and lambda is equals to 4200 and the d equals to 1.5 meter divided by small d, that is 0.3 millimeter, and here 4200 angstrom it is 4200 angstrom, that is 10 to the power minus 10 into capital D is 1.5 meter. So this is equals to, so we can get here this is equals to 4 1 ja, and it is 5 ja, 2 ja, that is 84,000 into 10 raised to minus 7, and this can be written as 8.4 into 10 to the power of minus 3 meter. This is the distance, or else we could write distance of the n1 is equals to 8.4 millimeter. So they are coinciding now, so therefore we can write xn1 is equals to xn2. This is equals to 8.4 millimeter. Okay, let me go for the next question, that is calculate the half-life and mean life of radium-226 of activity 1 query. Given the mass of radium-226 is 1 gram and 226 gram of radium consists of 6.023 into 10 to the power of 23 atoms. Here the activity of the given radioactive substance is 1 curie, that is 1 curie. That should be written in SI unit, that is 3.7. 1 curie equals to 3.7 into 10 to the power of 7, 10 to the power of 7, 11, 10 to the power of 10 becquerel. Now we need to find out the half-life and mean lives. So for half-life, we know that the half-life period is equals to 0.693 divided by decay constant, that is lambda, and the mean life, that is tau, equals to 1 divided by lambda. So we, to find out half-life as well as mean life, we need lambda, that is decay constant we need. Here we have activity, that is a rate of disintegration of radioactive substance. This can be written as, that is lambda n. We know that rate of disintegration of radioactive substance is equals to n lambda or lambda n. So lambda can be written as, now lambda is equals to A divided by n. Now substitute the value of A, that is activity 3.7 into 10 to the power of 10 becquerel. But we don't have number of atoms which are present in 1 gram of the radium-226. So let's find out now the number of atoms present in the 1 gram of radium-226. We know that for this we can write, we know that here 226 gram of radium consists of 6.023 into 10 raised to 23 atoms. Now we need to find out 1 gram of atoms, or 1 gram of radium consists of how many number of atoms. Let me take this one as n. Do the cross multiplication. We will get n is equals to, so therefore n is equals to, if you cross multiply this, you will get n equals to 6.023 into 10 raised to 23 divided by 226 gram. 226. This is equals to, n is equals to, we will get 6.023 divided by 226 is equals to 0.0266 into 10 raised to 23 atoms. So now we can have lambda here by substituting n. So therefore lambda is equals to, here lambda equals to, because of this reason we can write A equals to 3.7 into 10 raised to 10 divided by n is equals to 0.0266 into 10 raised to 23, and this is equals to, so therefore lambda is equals to 3.7 divided by 0.0266 is equals to, we could write this one as 139.0977 into 10 to the power of 10 divided by 10 to the power of 23, 10 to the power of minus 13 per second. This is the value of lambda. Now after getting lambda, we can find out half-life and mean life very easily. So we know that the half-life is equals to, just now we have seen that half-life is T half is equals to 0.693 divided by lambda. Just now we got lambda, that is 139.0977 into 10 raised to minus 30. So when you calculate, you will get half-life, that is T of is equals to, I'm simplifying this, we'll get half-life 4.982 into 10 raised to 10 second. This is the half-life period of the given radioactive substance. Next, we need to find out mean life. So mean life is equals to tau equals to 1 divided by lambda, that is 1 divided by lambda. In place of lambda, I have to substitute 139.0977 into 10 raised to minus 30. This is equals to 7 point, on simplifying, we will get 7.189 into 10 raised to 10 second. Okay. This is the mean life. So half-life and mean life of the given radioactive substance. Okay, this is the solution for this question. Thank you one and all. Thanks for watching. Thank you.